Hello once again for our module number 2 in Mathematics 10. We will be discussing illustrating an arithmetic sequence. To start with, please subscribe, share, and like my YouTube channel. So let's begin. So for our objectives for this lesson are the following. Define an arithmetic sequence, illustrate an arithmetic sequence, and solve problems involving arithmetic sequence. So let's define arithmetic sequence. Okay? A sequence in which term after the first is formed by adding a fixed number to the preceding term is called arithmetic sequence. The fixed number or constant is called the common difference denoted by B. Again, the constant is called common difference and we denote it with letter D. Okay? So let's continue. Say for example number 1. Determine if the sequence is arithmetic or not. If it is, find the common difference and the next three terms. Take note. We will determine first whether the sequence is arithmetic or not. So if we're going to observe the given numbers, observe that there is a pattern. Simply, we're going to observe the number between each term. There is a pattern wherein it adds 7. So therefore, this is an arithmetic sequence. So let's check whether it is really an arithmetic sequence. First, we need to find the common difference. So here is the solution. Okay, so we need to find the common difference. So solution, we will subtract the second term by the first term. Take note, second term minus the first term. And also, we will subtract third term by the second term. And also, it follows fourth term by the third term. Take note, we subtract the preceding number, okay, by the previous number. Okay? So for this case, let's now subtract. First, we have a sub 2 minus a sub 1 equals d. Meaning to say, subtract the second term and the first term, whatever the result, we call that d or common difference. If in case that all the solutions that we're going to do has the same result. So let's now start. Take note, we will subtract the second term minus the first term. And it is not stated that we will subtract a sub 1 minus a sub 2. This process is wrong. Instead, the correct is a sub 2 minus a sub 1. Second term minus the first term. Okay? So let's now continue. So let's substitute this notation. So we have now, for a sub 2, the value is 3. Minus the first term, a sub 1, which is negative 4. So 3 minus negative 4 is equal to 7. Okay, so we have 7 as the difference in subtracting the second term and the first term. So let's go to the next. So subtract a sub 3 minus a sub 2. Whatever the result, we call that difference. Again, a sub 3 minus a sub 2. So, we do not subtract it as a sub 2. Wait. So, we do not subtract as a sub 2 minus a sub 3. Instead, a sub 3 minus a sub 2. So again, this is a wrong concept. So let's continue. So let's substitute. A sub 3 is 10 minus a sub 2 is 3. Take note, we will now subtract the third term to the second term. Okay? So we have now 10 minus 3 equals 7. So meaning to say, from the first difference, we have 7. The second difference is also 7. So let's proceed to the third one. Subtract. Okay, let us now subtract the fourth term and the third term. So meaning to say, we have a sub 4 minus a sub 3 equals d. Again, a sub 4 minus a sub 3, and that is not a sub 3 minus a sub 4. That concept is again wrong concept. It should be a sub 4 minus a sub 3. So let's continue. So let us now substitute the given equation. So a sub 4 is 17 minus a sub 3, which is 10. 17 minus 10 is also 7. So if you are going to observe, we have the same result. So meaning we call this common difference. So the common difference is 7, or D is equal to 7. Okay, so we have now an arithmetic sequence with a common difference of 7. So let's now, since the given sequence is arithmetic, then we will find now the next three terms. Okay, since we know already the common difference, which is 7, we can now find the next three terms. So here is the solution. Okay, so we have to find the fifth term. Since a sub 1, a sub 2, a sub 3, a sub 4 are given, and we need to find the next three terms, meaning that we need to find a sub 5, a sub 6, and a sub 7. Okay, meaning the next three terms, since we are given the first four terms. So let's now start. So to find the fifth term, or a sub 5, we need to add a sub 4 and the common difference. A sub 4 plus the common difference. As you can see in our pattern, we add 7 to get the next term. So therefore, to continue this, we substitute a sub 4 by 17. So we have a sub 5 equals 17 plus 7. Then a sub 5 is equal to 24. Okay, next, to find a sub 6, we need to add a sub 5 and the common difference. So a sub 6 is equal to 24, which is a sub 5 plus 7, then a sub 6 is 31. How about a sub 7? So to find a sub 7, or the seventh term, or the third term for this given problem, we have a sub 7 equals a sub 6 plus 7. Substitute, we have a sub 7 equals 31 plus 7, and a sub 7 is equal to 38. So meaning to say, the next three terms are 24, 31, and 38. Okay, next, example number 2. Write the first 5 terms of the arithmetic sequence with 5 as the first term and with a common difference of 2. Take note, we need to write the first 5 terms, and it is stated that this is an arithmetic sequence. Okay, with 5 as the first term and with a common difference, or D, negative 2. Okay, so take note, find or write the first 5 terms with 5 as the first term. So let's now show this solution. Okay, so we have a sub 1 is equal to 5, or the first term, and D is equal to negative 2. Take note that to find the next term of a given arithmetic sequence, we just add the common difference. So to find the second term, or a sub 2, we have a sub 2 is equal to a sub 1 plus D. and a sub 2 is equal to 5 plus negative 2. Take note, the common difference is negative 2. What we need to do is just add it to the preceding term to get the next term. So we have now a sub 2 equals 3. We know that 5 plus negative 2 is equal to positive 3. So we have a sub 2 equals positive 3. Next, a sub 3 is equal to a sub 2 plus d. A sub 3 is called the third term. Substitute, we have a sub 3 equals 3 plus negative 2. 3 is our second term from the given solution. So 3 plus negative 2 is equal to positive 1. So a sub 3 is positive 1. Next, a sub 4. So a sub 4 is equal to a sub 3 plus d. Then a sub 4 is equal to 1. 1 is our third term plus the common difference, negative 2. And our a sub 4 or fourth term is negative 1. So we have now a sub 5 or the fifth term. Substitute this, we have a sub 5 is equal to negative 1, which is our fourth term, plus negative 2, then a sub 5 is equal to negative 3. Therefore, the first 5 terms are 5, 3, 1, negative 1, and negative 3. Third example, find the common difference of the arithmetic sequence 3a minus 1, 3a, and 3a plus 1. Take note that we are given this given sequence and we are asked to find the common difference. Find the common difference of this arithmetic sequence. Now, observe this given sequence. 3a minus 1 is called the first term or our a sub 1. 3a is called the second term or a sub 2, and 3a plus 1 is called the third term or a sub 3. Therefore, we are given the first three terms of this arithmetic sequence and we are asked to find the common difference. Okay, so here is the solution. So first, we need to look at this one. We know that to find a common difference, we subtract the next term by the preceding term. Subtract the next term by the preceding term. Meaning, to find the difference, we need to subtract a sub 2, which is 3a, minus a sub 1, which is 3a minus 1. So let us now substitute this equation. So we have difference or d is equal to a sub 2 minus a sub 1. Then we have a sub 2 is 3a minus 3a minus 1, which is our first term. Simplifying this using the distributive property, then we have d is equal to 3a. Negative times 3a is minus 3a or negative 3a. The negative or minus times negative or negative times negative is equal to positive 1. Simplifying this, we have to cancel this. We know that 3a minus 3a is equal to 0 or simply cancel. Then d is equal to positive 1. Therefore, in our solution, our common difference is positive 1. So let's try another solution. What if we're going to subtract a sub 3 and a sub 2? Take note, third term minus the second term. Okay, so let's look at this one. We will now subtract the third term minus the second term. So let's see the result if we use this equation. So let us now substitute this given equation that d is equal to 3a with 3a plus 1, which is the third term, minus the second term 3a. Again, simplifying, we have a like terms. So we need to cancel this. 3a minus 3a is 0 or simply cancel. Then d is equal to 1. Take note, d is equal to 1 also. So whatever solution we're going to use, either second term minus first term or third term minus second term, we will still have the same result, wherein the common difference is positive 1. I hope you can follow how we arrive with positive 1. So now, for our example number 4, find the value of A to make 3A plus 1, 4A, 6A plus 1, an arithmetic sequence. Take note, in this problem, we are asked to find the value of A in this given sequence. We have 3A plus 1, 4A, and 6A plus 1. Now, in this solution, observe, okay, so we need to have this equation, and let's verify whether this is true or not. Okay, look at this one. If we subtract a sub 2 minus a sub 1 is the difference, we know that if we subtract this, we call that the result as difference or D. Is it equal when we subtract a sub 3 minus a sub 2? We know also that the result here, subtracting a sub 3 and a sub 2, that is also D, correct? So therefore, it is understood that when we equate these two difference, we will get the same common difference. So let's now try to solve this one. Okay, from this given, since we are asked to find the value of A, let's try to substitute now our equation. Okay, so here is now the substitution and the solution process. So we have now, look at this one. Okay, so A sub 2 is 4A. So this one is our A sub 2. We know that 3A plus 1 is A sub 1. 6A plus 1 is our A sub 3. So substituting this equation, A sub 2 minus A sub 1 is 4A, which is our A sub 2. Then A sub 1 is 3A plus 1 equals A sub 3 is 6A plus 1. So this is 6A plus 1, which is our A sub 3. And our A sub 2 is 4A. Okay, so let's now simplify or solve this equation. So we now simplify the left side of the equation. So in this case, we will use distributive property. Okay, distributive property. So 4A minus quantity 3A plus 1 is equal to 4A minus 3A minus 1. Negative times positive 3A is negative 3A, and negative times positive 1 is negative 1 equals, okay, so let's simplify this. We have similar terms, 6A and negative 4A. So that is equal to 6A minus 4A is equal to 2A plus 1. So on this solution, let's continue. So we have here also similar terms, 4A minus 3A. The result is 1A or A minus 1 equals 2A plus 1. So let's now transpose or solve for A. So we have now to transpose positive 1, move it to the left side. So we have now negative 1. If we transpose positive 1 to the left side, then we have negative 1. So that is equal to 2A minus A. We will also transpose positive A to the right side. So this becomes negative A. I hope you can follow. So now, from this solution, negative 1 minus 1 equals 2A minus A is equal to negative 2 equals A, or A is equal to negative 2. So therefore, the value of A is equal to negative 2. Example number 5. I was advised by my physician to walk each day in the morning as a daily exercise. On the first day, I walked 40 meters. On the second and third day, I walked 60 meters and 80 meters respectively, and so on. Which of the following is the distance I walk on the 10th day if I continue the pattern in my daily walk? So let's now show this solution. Okay, first day, it says in the problem that I walk 40 meters or 40. For the second day, I walk 60 meters. For the third day, I walk 80 meters. The question is, if it continues in this pattern, okay, what is the distance on the 10th day? So if we will continue this up to the 10th day, and the pattern continues, then we have on the fourth day we have 100 meters, fifth day is 120 meters, sixth day is 140 meters, and so on and so forth up to the 10th day. Then we have 220 meters. Therefore, the answer for this given problem, in the 10th day, the distance traveled is 220 meters. Our next topic for the next video lesson is arithmetic means and term. Thank you for watching. Again, please subscribe, like, and share.